a lot of transformative changes. Then we
So we are live.
see that in all these areas, the technology is going to bring.
I think you have put video of teaser
No,
video, right?
ma'am, there's a delay between what I do on my laptop and what comes. So we'll start in just a
Yeah.
bit. Right. So we can start. Kabir?
So good evening, everyone. To spread awareness about unmanned technology, Team Nucleus would like to introduce Dr. Akash Sinha of Srinath University. On behalf of Team Nucleus, we would also like to welcome Mr. Matthew, Head of Connected Learning at SNS Noida, Ms. Madhu Negi, Vice Principal of Vidyagan Bulandshahr. Dr. Akash Sinha is an Assistant Professor of Practice at the Department of Electrical Engineering in Srinath University. He teaches robotics and embedded systems to about 500 students every year.
Professor Sinha has also founded a startup, Omnipresent Robotic, which builds smart autonomous drone solutions for industries and agriculture. He also led the Omnipresent team to develop navigation software for Chandrayaan-2, Pragyan rover, and earlier helped build navigation module for Chandrayaan-1. Professor Sinha is a recipient of prestigious MIT TR35, or MIT's list of top innovators under the age of 35. He has also received the US Cody and the DARPA Robotics Grand Challenge finalist medal.
Autonomous robot navigation software, where analytics, modeling, and control and kinematics of autonomous is an amateur astronaut and has been doing backyard astrophotography with his telescope. To set an observatory at SNU.
We would now like to call Mr. Matthew to jumpstart the session.
Wow, what an exciting session. Good evening, everyone. To have people from SNU combining with school students on a topic that's so relevant, and how exciting to be able to bring this topic outside the classroom, to be able to connect people to what I hope will be some of their personal projects in the weeks to come. There's a lot of learning to happen, and it's not just going to happen tonight. So I hope everyone, whether you're watching this live or you get to see the recording, will actually be as excited as I am. There's not much more relevance than you can get with robotics in today's world, the things that it's doing now and what we will do in the near future and in the far future. So I welcome our collaborators, Miss Vanita and her team, the SNU team, the students. It is just so exciting to literally be what we say in a connected learning environment. We are not just one school, one classroom, we are a community of learners. So welcome to tonight. I'm excited to be able to listen to this discussion and how it can add to your learning. So good luck and enjoy. Thank you very much.
Thank you so much, sir, for such an insightful message. And any questions that audience might have, they can put that question in the chat box on YouTube. We'll keep on resolving those questions throughout the session. Now, I would like to call Dr. Akash Sinha to start the session.
Thank you so much, Harsh. Thank you, Kabir. Thank you, Mr. Matthew. Really excited to be here. I know we are in tough times. Some of us may have gone through, seeing a sick family member. And so it's really good that we can still keep connected and activities can happen. And, this is what this connected learning is about. So what we're going to discuss today is essentially how unmanned robots or unmanned technologies, or if we put it very simply, I would say drones and driverless cars and some similar robots, how they can help, how they are helping during the pandemic, and how they will help us in this new normal, and how they will help us beyond the pandemic. So that's the outlook, and hopefully we can encourage some of you to take this field and build a career here. So I'll start. I have a few slides. Let me just share my screen. Just give me a moment. Meanwhile, maybe Kabir, if you can just confirm if you can hear me clearly. If there.
Yes, sir.
Just 1 second. Let me just share the entire screen. Okay, that's better. All right, and also let me know if you can see my screen.
Yes, yes.
All right, good. There are a couple of videos during the presentation, so just let me know if there are any issues with that. So anyway, so students and teachers, educators, hobbyists, whoever is joining it, very warm welcome. As I said, we'll be discussing autonomous robotic vehicles today, and this is about the technology during and beyond the pandemic. So I'll first start a little bit, with my journey. I think a lot of it, one of the students already covered, but here's what I summarize my journey based on, some of the robots that I got, that I was fortunate to work upon. So if you see, on top left is something called DARPA Unmanned Car Challenge. And this is like almost 15 years back. And I would say this is the precursor to driverless cars. So you could see, you could see this vehicle on top left corner. It's a little Ford truck, and this is probably one of the first driverless cars. So it was great to get started with that. I was just a graduate student at that time, and then I worked for this company called iRobot, which used to make military robots. So we made some robots that could, dispose bombs. They could go out in a war field, collect information, and nowadays they are even being, mounted with guns. So interesting technology. And then on the bottom left, you see an unmanned tank called Spinner. This was a 6,000 kg unmanned tank. It was an invertible tank, so it could actually invert and still keep on going. So again, an amazing robot to work upon. While I was doing my master's at CMU, I got to work on this, and my master's thesis was also based on this. And then on the bottom right, you see a Yamaha RMAX. This is probably the first UAV I got a chance to work with. And again, this is almost 13, 14 years back. So a lot of great learning, and then I took this learning and I applied it back home when I came back here. And these are some of the robots I got to work on in India. So the first one is this Chandrayaan-2 rover called Pragyan. Unfortunately, this rover didn't quite come out, but it's going again in Chandrayaan-3 mission. And when it comes out, a lot of navigation software for this robot was developed by my team. And then you can see there is on the bottom, there's a multi-rotor called Garun UAV, which is used a lot in industries and factories for inspection of assets, inspection of chimneys and flares, things that are very difficult to inspect for a human. Maybe there are, so for example, if something is 100, 200 meter high, it's very difficult to inspect and maintain for a human. And then there's also a plane type UAV that we developed. This is used very wide scale for mapping. And, the good thing is that you can create 1 centimeter type resolution maps with this. So another great technology on the blocks. On top left, you see something called Robot, a river cleaning robot. So some of you might have visited Yamuna or Ganga, and you can see there is a lot of our rivers have become very dirty, and this is something that a machine can definitely do. So when we did this project, actually it was covered by a US media called Channel One, and they actually showcase it in all of their schools in US. That's what they told me, to inspire the students over there. So let me also play this video, and hopefully, Naman or Kabir can confirm if they can see the video. So I'll just let this video run through, and then we can talk a little bit about this.
This is something that you have to.
Okay, I don't know if
Yes, sir, we can hear it.
Volume is a problem.
yes, ma'am. Volume.
Volume is a problem. Otherwise, we can see video very.
Okay. All right. Let the video just run. I'll talk about it. Okay, so it's done. So, anyways, maybe there's some problem with the audio. So, but I'm sure you must have got the gist of it. And I also hear that our Shivnadar school students have developed a very nice river cleaning robot as well. So, be very excited to interact with them. But as you can see, see, the one thing about India is that you might say there are a lot of problems, but another way to look at it is that there are a lot of opportunities to solve a problem. And that's how, I think, I would say a lot of enterprising kids should look at it. So you can pick up a problem. Let's say the river is really dirty, the air is polluted, or, in the pandemic, the virus is spreading really fast. And now you can think about, is there a way I can solve this problem using technology, especially? And if you can figure out a way, that is something that where, I think a lot of opportunities to build something, to solve a problem, and do something about it. So let's move on a little more from this. Okay. There are a few accolades. I think Naman already talked about them. TR 35. Okay, I'm not under 35 now. This is a few years back. This is about 50 plus drone deployments that we've done across India as part of our startup, whether it's in defense, oil, gas, telecom. So one of the reasons I wanted to show this was just for you to know that how much of the technology has already progressed in India. And there are a lot of places using unmanned technology, drones and robots. So let's discuss a little bit about the technology during the pandemic and beyond the pandemic. What can we do as far as the pandemic is concerned? What has been done, and what are the things that can be done in the future? And what are the other problems that this technology can solve? So here are a few examples that I saw live happening in India, where a lot of drones and robots were used. So one of them is delivery of emergency medicine supplies, including vaccines, medicines. Even emergency, oxygen concentrators can be shipped up because some of the drones can carry 20-25 kgs. And secondly, also, transporting blood, plasma. And why you might want to do this. So most of this, using the drones has been done in trials and not so much on a, on a larger scale, because obviously, people were overwhelmed with the pandemic. However, one of the things with this is that suppose, in future when a new wave comes, if it comes, let's hope it doesn't. But if there is a hotspot zone, it can be sealed off, and we can send a robot or a drone there. Whatever supplies, packages, medicines have to be sent. You don't have to. It doesn't have to be carried by a human. So it can be carried by a robot. So that will curtail the transmission of the disease. And some of these trials have already happened in the state of Telangana, and I'm sure we'll see this happening more and more. Another thing that has happened is doing thermal screening. Now, this can be done again. We can't do it in the current stage, but it has been tested in when the pandemic was not spreading that fast. So in a crowd, you could detect people with fever with a low-flying drone that has a thermal camera on it. So that's another, use of unmanned technology that can be applied. One Indian company, I think it's a Bangalore-based company, they have developed a robot that can be used as a nurse as well. It can carry medicines, it can carry food, it can remind people when to take medicine, it can start a conversation, it can help people stand up and walk. So essentially almost kind of being a nurse. And we know that we are facing shortages of nurse medical staff, and they've been working 24/7. Many of them run out, and so perhaps a little army of robots could help. Maybe they can't do everything that the nurse does, but they can definitely assist them and help be a force multiplier there. Another thing that has been used very widely during the pandemic is large-scale sanitization. And so large-scale sanitization has been done to sanitize public places. So we know, IPL was going on earlier, and although there was no crowd there, but in order to maintain this, bio bubble, as they were saying it, they were using these drones with sprayers and spraying out an entire stadium, and again, really effective technology. So imagine if in a few weeks when the lockdown opens, temples and mosques will open. So these are large public places, and this is something that can be sanitized aerially with a bot. So these are some of the examples. And then, now this is something what can be done during the pandemic. However, if you see what can be done even in a longer run, so beyond the pandemic, there are multiple uses where, if you get into this technology, you can build. Okay, so there's a video, but I'll show it a little later. So beyond the pandemic, there are some really big areas that are coming up. So one of them is basically food and e-commerce delivery. Now imagine again, and it has obviously it becomes more relevant during the current times because doing a delivery via a drone or a robot means it is going to be completely contactless delivery. So, but imagine, you are sitting here in Shivnadar University, and maybe some of you like food from a far-off restaurant. Let's say, somebody prefers to eat parathas from Murthal. So the drones can actually, carry a food package or an emergency delivery package in about, even something that's 50 kilometers away aerially, and bring it in about half an hour. So, there are these drones, some of them have max speeds of up to 100 kilometers per hour. So they can cover 50 kilometers aerial distance in about half an hour. So just like you have 30-minute delivery in a lot of, food cases, you can have this using a drone. And the Government of India, Ministry of Civil Aviation, with special permission for beyond visual line of sight drone operations for emergency use. So that already authorizes them to do things like medicine delivery and vaccine delivery and blood delivery. However, food delivery and all will probably take a little more time. Elderly care is something, it's very big internationally, but even in India, it's something that is coming up now because, typically in a family, husband, wife, both are working, kids are going to school. So, you need somebody to take care of the elderly. And a lot of elderly robots, personal care robots, this is something that can get in every home. So it can become a really big market, especially in the urban India. Precision agriculture is something that, forgive me for the typo. I wanted to write boost, but it has come up as boost. So anyway, precision agriculture is something that is going to be quite big. Why? Because half of our land is agricultural land. And, right now the agriculture is not being done in a, I would say, a very measured way. So it's mostly it's mostly based on the experience of the farmer, how they do it. And if we do precision spraying of fertilizers, precision spraying of pesticides, and even precision irrigation, and also do crop health monitoring. Now, all of these can be done with drones and robots. This can boost agriculture yield. In some studies, it has been shown up to 20%. Now, imagine our GDP is, half of our GDP comes from agriculture. So if we boost agriculture by 20%, it's almost like boosting GDP by 10%, So obviously, actual numbers may not go that high, but even boosting the GDP by 1% is a big number. So this is something you will see in coming few years. We've already seen a lot of places starting to use drones for agriculture, especially large farmers. So the only problem is that a lot of farmers have really small land, and then it's not affordable for them to use a drone. But for large farmers and with these new farmer groups coming up, it will become viable. Next big field that will come up is defense and security. Now, this is something where you will be able to fight wars without endangering soldier lives. So basically, these robots will have a gun mounted on them. They'll have cameras, and they'll be completely teleoperated. So just like you can see there are these unmanned armed drones, and now you can also get these unmanned armed robots that can go, guard our borders and fight wars for us. And this is something. This is close. This is actually fast becoming a reality. U.S. Army uses more than 20,000 of such military robots in various operations. So I'm sure this is something this is catch up fairly quickly in India as well. So anyway, these were the areas where we'll see this technology develop. But now we can talk a little bit about the itself, and we'll try to do it in really simple terms. So let's talk a little bit about what is this technology, how it works. And so the heart of any autonomous robot is essentially oh, by the way, before I go there, I did miss out on one of the videos. Again, if volume is a problem, we'll just talk about it a little later, or I can just mute it. Let me just mute it. Is volume okay, ma'am? It's just music. So anyway, this is I'm not sure what happened. Just 1 second.
It was audible initially.
Okay, it was audible. Wait, just trying to get rid of this. Okay, just give me a moment. Can you see the screen, or is there something on the screen? This chat Teams is.
Yeah,
No.
chat Microsoft Teams can be
I'm
removed.
not sure how to get rid of it. Let me try to get rid of it.
It'll just go away automatically. Just stop hovering over
It will go automatically.
Kabir is
Yeah,
saying,
it does. All right. All right. So this is a e-commerce company that is doing trials of e-commerce delivery. This company is called ShopX, and they're doing these trials in Bangalore. So it will soon happen. Now this is warehouse to warehouse. So from one warehouse, somebody loads, let's say, a package with iPhone, and then this will travel and go into another warehouse. So the pilot basically just selects on the phone, from point A to point B where it needs to go. The drone will catch. So you see, one of the challenges with doing drone-based delivery is that, if you try to deliver it to somebody's home, you never know. People might just capture the drone and don't return it. Maybe they didn't like the package. So how do you ensure that kind of safety? So one of the things was to, instead of doing delivery to homes, was thought that maybe you can deliver from one point to another. This is just another point. And once the drone travels, gets to the next warehouse, will go and land there. This is where the drone is going to land. This kind of thing can be useful for somebody
Dr. Sinha, your voice is cracking. Now, it was pretty clear, but now your voice is cracking.
Sorry. Oh, sorry. You're saying, is my voice audible?
Now it's okay.
Okay, maybe it was because of the music, it wasn't audible. Let me just repeat that. What I was saying was that I was giving an example of why this kind of technology would be useful. Is that can you hear me?
Yeah, now it's okay. You can mute the video voice sound and you can speak about it, and you can just display the video.
Okay, the video you're able to see, no?
Yes.
Okay, I can just talk about it. So basically, in the video, what we saw that there was a delivery that was done from one warehouse to another warehouse. And this is much simpler to accomplish than delivering to somebody's home. Because delivering to somebody's home, there are other issues as to how do you ensure the safety of the drone itself. And there might be highly unstructured environment over there. So imagine if somebody wants to, let's say, order an iPhone in Dadri and it's not available there, but it's available in Gurgaon. So the shopkeeper from Gurgaon could deliver it in Dadri to another warehouse location, and from there it can be delivered by somebody on bike or something. So these are the kind of things that this technology could ease out in future. So anyway, we talked a lot about technology. Let's also now look at how this technology is built. These there'll be some very simple basics that we'll look at. You don't need to have any particular technical background to be able to understand this. So we look at the autopilot. So for all these autonomous robots that you saw, whether it was a drone or it was a driverless car or it was that autonomous nurse, they all need an autopilot. So autopilot is the heart of these robots. And what a robot is really made of is that, we can divide it into 3-4 main parts. So basically, robot is a machine that senses, thinks, acts, and then also learns. Now, some of the robot may not learn, but most of the smart robots do learn. And so every time a robot wakes up, it senses the world around it. So maybe it has cameras, and from cameras it will sense the world, and then it will think about what it has saw, what it saw, and for that maybe it has a computer, maybe it has a microchip, and then apart from that computer, it has a set of algorithms that analyze, think, and take a decision. And these set of algorithms are called an autopilot. So thinking has a hardware component and a software component. And the software component of thinking is what's known as an autopilot. And then once the thinking has been done, then the robot takes an action. So which can be taken by motors or actuators, And then once this sense, think, act has been done, one iteration, the robot learns from this iteration, or it might learn from some previous data, and then again, continues this iteration. Am I clearly audible?
Yes, sir. Very much.
All right. So this is called the sense, think, act, learn paradigm. This is how, when I learned first robotics, this is how we were also taught, and I think it's a very useful paradigm to understand the robot. So now, what's really inside an autopilot? So remember from this slide, autopilot is essentially the software of this thinking part. It's the set of algorithms that help the robot take a decision. So here's a typical problem that a robot faces. So let's say we have a driverless car. See, there car of, let's say, 6 wheels, and it is at a point A. It's going in this vertical direction, and then it has go to a point B. And when it tries to go from point A to point B, there could be things in the way. Maybe there is no road there. Maybe there is a vehicle standing there. So there could be a lot of issues. But the basic problem that an autopilot tries to solve is just this, that the robot is at a point A and it needs to get to point B. So what's the best path to get to point B? So whether you are a drone or a driverless car, essentially the autopilot at every step is trying to guide the robot how to get to your next point. And how does it do that? So there are about 4 or 5 algorithms that work in tandem to do that. And we'll just look at those algorithms. Oops, let's go one by one. So the very first thing that the robot does as soon as it wakes up is that it sort of asks a question. Suppose if you might have seen in some movies that a robot wakes up from coma, and then a human wakes up from coma, and then the first thing that human asks, okay, who am I, where am I, and all those things. And so this is what happens when a robot wakes up. The first thing it asks is, where am I? Where am I in the world? And also called localization. And one of the key localization sensors, all of you know, is a GPS, just like, the GPS tells your car where it is and so forth. But, sensors have a lot of errors. So there is an algorithm that combines data from multiple sensors to tell the robot its position. And this algorithm is called a Kalman filter. Kalman filter is also used in many other applications, wherever, you have to estimate something based on multiple sources of data, which might have errors. So once the robot knows, okay, where am I? Now it knows that it is at point A. The next thing it asks is, okay, what does the world around me look like? So now the robot knows it is at point A and it has been given a task that you need to get to point B. So now it wants to understand, what does the world around me look like? Is there a car in front of me? Is there a road? So this process is also called mapping. And a very common mapping sensor is a camera. And there are other mapping sensors like a LiDAR, radar, and so forth. So any sensor that just tells the robot information about the world. So localization sensors tell the robot about itself. So for example, localization sensors examples are GPS, accelerometer, gyroscope, compass. All of them tell the robot about itself, about robot's own position, its speed, its velocity, its angles, and so forth. And then mapping sensors tell the robot what does the external world look like, what is around me. So using those mapping sensors, the next step the autopilot does is that it builds a map of the world. And one of the most common mapping algorithms is a grid-based mapper, which basically forms a little grid in which a map is generated. So it's like, again, if I compare the analogy of a man coming out of coma, you could say that the first question was, where am I? And then the second question is also about, and what do I see around me? Are there people I know? Am I in a familiar city? And those things, what's around me? Am I on a bed? Is there a door around from where I can go out, and so forth? So this is what mapping is doing. Now, once the mapping is done, the next step is how to achieve the goal. So this is also called planning. So now I know I have to get from point A to point B. I know what's in the way. So now I can plan a path around it. So this is also known as path planning, and there are several algorithms that do that. These are also known as path planner algorithms. So once path planning is done, then just like in real life, you can create a lot of plans, but when it comes to execution, a lot of plans go haywire. You may have to change. You may have to constantly update your plans. So this is what is known as robot control. The control is trying to, it's an algorithm that's trying to keep the robot on its desired path. And one of most common control algorithms is known as PID control. So once the robot is going on its path and it's being controlled, if it moves away from its path, course corrections are done. So that will now, now once that is done, then the last step is actuation, where you see the action, where the robot moves. Maybe its wheels moves, or hand or legs move. And then once the robot has moved, obviously its position has changed. So again, it goes back to the same cycle and it asks, where am I? So anyway, this is a very simple description of an autopilot. And almost all robots, whether it's a drone or it's a Tesla car or it's a missile or even a space vehicle, they're actually using a very similar autopilot. Maybe there's some difference in implementation, but the basics are very similar. And if some of you who have been taking my robotics course, they're probably familiar with this description of an autopilot. So, and we'll try to make more material available to all the students, including our school students, so that they can refer to it in more detail. For the purpose of the talk, we'll just stick to this much for now. We just wanted to give you a flavor of what an autopilot is like. Okay. So now that you know a little bit about the autopilot, how can you build your own? Well, so the great news is that some of our students have taken this initiative, and I'm really happy to see how enterprising our students from SNU and SNS are, and they've taken this up, and they will help you build your first robot and drone. And then you can receive additional mentoring from SNU as well as SNS faculty, our teachers, professors, everyone is ready to help you folks. I believe Kabir and Naman, you guys have prepared something on it. Do you want to discuss it now or discuss it later?
Can we just ask the questions from audience, Gulfam sir first? And then, because students are asking questions in the chat box on YouTube.
There's a small portion of the presentation left, which is about how to build a career. Should we do that now, or you want to take a few questions first?
I think you should take a few questions right now, and then you can continue.
Let's do that. Yeah. And then we'll do the next part of the talk. All right. So,
are you going to speak about question, or should I speak, or Gulfam sir? Because I'm right on YouTube.
All right. So, where are the questions? They are available in the chat.
Yeah, I will just ask you question which is on YouTube chat box.
Okay.
So one of the student is asking, sir, how is security against hackers ensured in such a large scale system of drones or war robot? Does it make the system vulnerable to hackers? This is Nitin, class 11, SNS Noida. This question has been asked.
Very good question, Nitin. In fact, there was an incident a few years back where accidentally an underwater torpedo was fired from a US ship, and apparently there were some allegations that maybe that those ships' computers were hacked, and so network vulnerability is definitely a big issue, not just in robots, but almost every defense system, defense network. And there are technologies that are really helping it. So some of them are basically blockchain powered, which gives them a lot of authentication powers which are difficult to hack. And then there are standard encryption techniques like 128-bit encryption. So many of these robots and drones use that, especially the defense ones definitely use that. And it also tells you that if you are planning to get into this field, actually there are a couple of supporting fields which will become very relevant. One of them is blockchain, and the other is cyber security, because both of them also apply to the robots. And yes, definitely it is a concern, but there are technologies to address it.
So is there any other question? Please ask.
Yes, sir. Yes, ma'am. Sir, I wanted to ask that we are going to use these robots in the field of military and army at very high rate. And at the same time, we also have the second law of the robotics which says that robots should not harm humans. Then do you think that big organizations in near future will agree upon using the robots for military purpose?
So you see, one thing about these, law of robots is that, this law of robots is sort of, it's kind of a hypothetical law. It's not really a law, it's not something that a robot has to follow. And so it's just made out hypothetically. Basically the robots do whatever they're programmed to do. They can be made into evil, they can be made into good ones and whatever. So keeping that aside, when it comes to military, whether we want or not, it is happening and it will happen, just like, nuclear bombs happened. And as I had mentioned that US Army has already started using many of these. And then there is a value that comes because you can save a lot of soldier lives. So, there's a really nice book about future of wars. I forget its name. I'll probably share it once I find it. It talks about how wars will happen in future, where you'll actually have robots fighting against robots, and most people, sitting and watching the war on a TV or internet or something. And the same will happen even in the air, where instead of fighter planes, you will see unmanned drones, combat drones fighting against each other. So definitely the military will use it. It's a big force multiplier for them, and you will see it happening. But yes, I think it just brings back to the safety point. What if somebody hacks your robot to fire on you? What if somebody hacks your drone to fire back at you? So those are definitely, safety concerns, and they apply, as I said again, to the entire range of defense equipment. And that's why I said cybersecurity and blockchain will become really big, when we get to address these.
There are many questions, Kabir.
Sir, so another question would be, what type of activity should we pursue for being ready for taking robotics as a career in the future?
So that's coming in the next part of the talk. So save those questions for later. Anything related to here, we'll first discuss it, then you can ask those questions. Anything related to the technology, we can discuss now.
There are many more questions, Kabir. Please ask.
Sir, I have a question.
Yes,
Sir,
please.
is there any pre-planning to manage the chaos that can be there in future to do the replacement of human labor by robots?
Okay. So again, it's a good question. Well, I can tell you what is being done for drones. So imagine if there is, in the future, if suppose we have drone-based deliveries happening across India. Now you will have these, thousands of drones flying across the sky, and it will be one nightmare to manage their traffic, and drones going rogue, and somebody trying to hack them. So what DGCA, the Director General of Civil Aviation, has come up with is something called a digital sky. Now it's really good to see, because this digital sky implementation, is about dividing the entire sky into digital bits. And digital bits, there will be pathways defined for each of the drones, and the drones will be fully autonomous. Or hack, or are somewhere, not following the norms, are the ones that will be tracked by a human, and the action will be taken against those. So there are these technologies coming up, and this digital sky, you can read about it, or check about it on internet. Again, I think it's a very progressive thinking by Ministry of Civil Aviation. I think they're thinking far ahead of even what people are thinking elsewhere in the world. And I think similar implementations might have to be done on ground-based robots. So if there are driverless cars running around, again, this might have to happen. Having said that, the robots, I think initially may not mix so much on a personal level. So maybe the drones and driverless cars also initially might run from point to point. So like you saw that example where, one drone was delivering from one warehouse to another warehouse. So in some way, the complexity will be managed, and there are already technologies coming up for that.
Good evening, sir. One question is there. Actually, coin has two sides, so that's why a question is there. So we are going to opposite side actually. So Rajat Kumar Singh, he's asking, sir, can these unmanned drones be hacked?
Of course. They can be hacked, they can be set against you. See, they're like a flying computer. So you just keep in mind that they're like a computer that's running some AI software. It has cameras, it has, it has engines, but essentially it's a computer running an autopilot. And it is communicating via a network. Any network is hackable. So, But what I was trying to say is that, it's a larger problem. It's not just a problem with drones. Even your missiles can be hacked. Even nuclear facilities can be hacked. Secure computers can be hacked. So I'm saying this in general is a problem that in any case needs to be solved, apart from robots. And most of the robots, at least the industrial level, they are using a good level of encryption and techniques to prevent hacking. Nevertheless, there will always be one great hacker which will find a way to break it. But then it's going to be this little chain where we have to find a way in which we can prevent such hacking happening. And I'm not saying that this is it's something that's going to be always hack proof, but there are technologies that are being developed, and hopefully as those technologies also mature, we will see that it will become increasingly difficult to hack them.
So next question is, actually we are humans and we are always possessive about our things. So Dinu Pandey is from grade 8 Vidyagyan School Bulandshahr. He is asking same thing. Sir, I have heard that because of robots, unemployment is increasing. So please elaborate, sir.
So there are a couple of perspectives here. One is that we've seen this happen throughout the history. When so let's say a little a little back in history, when printing press was invented, everybody thought that all the jobs will be lost. Industrial revolution came, everybody thought all jobs will be lost. When computers came, there was this Y2K. Okay, some of you may not be aware because you were not born around that time, but there was this Y2K thing where everybody said that okay, so anyway, there's a problem with dates, but beyond that, there was also a concern that as computers come, there'll be no jobs in offices. Everything will be done by the computer. But what we've seen that every time a new industry has come, it has created a different segment of jobs. And similarly, you will see that as these robots and AI and these things catch up, there'll be another segment of jobs. There'll be a lot of people who are building AI, who are building robots, building software, and so forth. Having said that, there is something different about robotics as a revolution, which is that, all the technologies that we saw so far, whether it was internet, printing press, computers, they were, obviously they made our job easier. But the thing with smart robots, and especially this phenomena that people call singularity, is that robots there will be a time when robots will be able to do almost every job, and they'll be able to do it better than humans. Just about everything, whether it is being a doctor, a lawyer, a teacher, fighting a war, and even writing poems and doing paintings.
So, sir, Anurag,
just about everything you can imagine. Yeah. Was there a question? Whether it's from a creative field, non-creative field, everything will be. Can you hear me?
Yes, sir. Yes.
We can. Okay. Everything you know will be done by robots, and it will be done better than humans. So now, when such a situation comes, then obviously robots can work for free. So why would somebody employ a human? So it is a genuine concern. However, I would say it's kind of far. It's probably not, the singularity is probably not coming in next 20 years. And at the same thinking about what to do. So there is a suggestion that Bill Gates has given. He says that just like we tax human salary, we should tax a robot. So if a robot takes up a human job, we should tax that robot on the same scale as we tax a human, and then use that tax money to pay everybody. So everybody should be paid, even if they're not working. So it will be kind of a social security. And imagine a scenario when, if everything a robot can do, then why is there a need to work at all? Then maybe we'll simply enjoy life, in whatever way we want to enjoy, and there'll be no need to work. So that's another egalitarian scenario. It's more philosophical than science, so it's difficult for me to comment on that. But I'm sure the society will evolve to figure something out there.
Yeah, sir. Thank you, sir. Anurag Singh is asking, sir, How
By the
can
way, I must
robot?
congratulate, I said the student was from class 5, no? The student who asked the question.
Yeah, sir.
So I must say, very creative question. I forget the student's name. What's the name?
1 second, sir. He's from eighth class, sir. Sorry for that. Dinu Pandit.
Dinu Pandit. Well, I must congratulate you. It was a very good question and very thoughtful for somebody in 8th grade.
Yeah, sir. Anurag Singh is also asking, sir, how can robot identify enemy in a war situation?
Okay. So that's similar to how, anything that a robot does, you can take an analogy from a human. So how would a human identify, let's say, an enemy? Maybe the enemy robots have a different color, they wear a different uniform. That's how you, even typically in a war, if somebody just comes in your country's uniform, you will not be able to tell whether it's an enemy or one of your own unless you actually recognize them. So it will be very similar, either through the uniform, through the color, through, from which side they're approaching. But at the same time, we can embed some technology. So for example, all the friendly robots can have a chip that has a code which they communicate, and that lets you know that, it's a friendly robot. And of course, the enemy robots won't know that. So that would be one way. But again, that's also subject to hacking. So, there will always be a little loophole that can be exploited.
Yeah, sir, this is a question from my side. Actually, I love robot, and I want to prepare a robot. So maybe our student also they want to pursue some career in that also. But from the beginning, like from the first day, from where should I start? My first machine, so that I can prepare easily.
So the first machine, the last slide I showed, the first machine initiative, some of the students have already taken up. And they will run this 2-3 week workshop and program. I think they'll do a little presentation about it, where you can build your first machine. We'll also try to see if this basic robotics course that I offer, maybe we can put it up online, at least for our SNS and SNU community. And that can get you started with your first robot. There are some really good online courses otherwise also available on Coursera and Udacity, and I think we have a account with Coursera, and I can recommend some of those. So those would be the things where I would start.
Thank you, sir. That would be like informative for our students also. Parth Joshi. Parth Joshi is asking, sir, if one wants to go in missile development, what should be the starting point?
Missile development, huh?
Yeah, missile development.
Very good. So although we are addressing a lot of career-based question in this next section, but anyway, now that you've asked something really specific, so missiles, so far only DRDO makes in India. So if I were you, I will try to get an internship at one of these DRDO labs that build a missile. At the same time, I would encourage you to take up an online course that talks about, the basic autopilot algorithms that I was talking. So localization, PID control, and these things, or a basic robotics course will also prepare you in that. So first I will take up a basic robotics course, brush up a few skills, and then try to do a project on my own, and then also try to get an internship at one of these DRDOs that are into building a missile. And that could probably convert into a full-time job at that DRDO. And that would probably be a way to build your career in missiles. So great example is our Dr. APJ Abdul Kalam. So He was associated with DRDO and ISRO, Indian Institute of Science. Those are the places where, having said that, I think in coming times, you will see private companies also getting into this sector.
Thank you, Dr. Sinha. Number of questions.
There are many questions still remaining. What I will suggest is we can put these all questions in the chat box, screenshot, so that Dr. Akash can, because there's so many questions coming every minute.
Right.
And these
Yeah, let's put them in the chat box. And because a lot of questions are about the career, we can talk about the career a little bit. Should I talk about the career?
Please,
because that will answer a lot of questions students are asking about the career.
There are questions for Kabir and Naman also, when the live class will start. So after your session, then they can also speak about it. Thank you, sir. Over to Dr. Kasina.
Sorry, I was having some network issue. Now I'm back. Okay.
So you can do the career thing, sir. After that, Akash and Kabir will sort, because students are asking when the live class is starting.
All right. So let's go to that. Okay. So here we are. All right. Okay. So this, as ma'am said, our students will present this, how to build your own first robot, as Gulfam had also asked. So we'll look at it. And as I said, we'll be very happy to provide mentoring, both from our school and our university, and help you build your first robot. Okay, so now if you're trying to build a career in robotics, here is why you should consider getting in this field. So one of the things is that you'll notice the traditional software industry might be slowing down. You will see, you hear this a lot. Having said that, jobs in robotics and AI are actually increasing exponentially. In fact, I'm part of this group, which is a WhatsApp group called Dronacharyas, which is a group of drone startup companies. And in that group, there are almost 100 drone startups already. And even I didn't know that there are so many drone startups in India. And even if they are really small, and even if they are offering on average only, let's say 5-10 jobs, even then you can see that there are at least 1,000+ jobs just in drone industry across India. And obviously, some of them are big companies; they'll have much bigger jobs as well, including Reliance is there in drones, Tata is there in drones, so Adani is there. So a lot of big firms are also already there, and they have definitely much bigger scales coming up. And these jobs are increasing really fast, as I said. Also, you will see massive disruptions happening in next 3 to 5 years. Also, the growth of robots and drones will get accelerated because of this new normal where social distancing is a norm, lesser human contact is a norm. So you will see a big impetus coming to drones and robots. There is an estimation by PwC. There's a report by PwC that estimates just the drone market. Other robots will probably have similar figures as well, to be $400 billion by 2025. So again, as I said that, this is a field that's coming up. If you are good in AI or in robotics, you will definitely have lots of job opportunities, compared to a standard, software engineer. I said some fields will also grow very well, including cybersecurity and blockchain. So those are also areas where that will be needed when you're building state-of-the-art robots. So how can you prepare? So the first step is to do a little project, build your own drone or a robot. And for that, perhaps the first step is to take at least some kind of an academic course, maybe an online course. And we'll try to see if we can offer something, if we can put something online as well. So first step, take some kind of an academic course, either online or through your institution, or through this new workshop that we are starting for you. And then build your own drone or a robot. So once you've done that, then the first thing would be is to try to get an internship, some industrial internship, either in one of the government labs or one of these robotic startup companies. And when you file for an internship, obviously they will like to see if you have built a drone or a robot on your own. So it's like a little, you can see it's a series of steps. First, you'll have to take some kind of a course or a workshop. Hopefully the student workshop that we are starting will help you. Then you have to build your own project or a robot, maybe put it on YouTube, talk about it. And then, once you've taken a course, you have done a project, you put that in the resume, and then you apply for an internship. And then once you've applied there, then you can probably, go and try to get a job. Having said that, there are different types of careers that you can build here. So these are the different categories. Excuse me. So first is that you can become an AI or a robotics engineer. And this also involves different types of jobs. It could be you could be a mechanical engineer who's designing the robot, its mechanics. You could be an electronics engineer, who's building the robot's embedded systems. But bulk of robotics jobs will be around writing the AI software for the robot. So bulk of it will be around developing the software for the autopilot. So a lot of jobs will be based on autopilot algorithms and AI and machine learning. And the path is straightforward. You have to do relevant coursework, then a project, and then internships, and then apply for the job. And definitely, our SNU and SNS family have a very good career center. You should apply through them. If some of you have done a project and a coursework already, feel free to reach me. I should also be able to connect you to some of the companies in this field. Some of you might also want to become an entrepreneur in this field. And this is a really good time to be an entrepreneur in robotics and AI, because there are lots of problems and a lot of solutions are needed. And so if you are one of those who can, who's not in a big hurry to get a job, you can invest 1 or 2 years and try your luck at entrepreneurship. And even if you don't succeed, trust me, you will definitely get a really good job. And 1 or 2 years of trying to build a company will teach you more than probably what you will learn in 7-8 years of working in a standard job. So there is, the learning curve is very quick when you're trying to build something on your own. And how can you become an entrepreneur in this field? So, or in any field, essentially, as I said, you have to look around. India is full of problems. Pick up a problem, try to develop a solution for it on paper. Try to find like-minded people like you with complementary skills. If you are good at technology, maybe you want somebody who's good at talking, who's good at selling, who's good at selling the product and selling your idea. Maybe he can impress an investor. He or she can impress an investor. And similarly, if you are one of those who's good at talking with people and selling an idea, perhaps you need to find somebody who's good at technology. So build a team and then build a prototype on your own. Don't jump first day saying, okay, now I have an idea, I have a problem, I have a team, and now I need money. Because, very few people will give you money at that stage. But if you can build a little prototype, even a duct tape demo, a really basic demo prototype on your own, get some, try to find some money from your professors or teachers or friends or family. And, it may not require a lot of money, just a few thousand rupees, try to build a prototype. Once you build a prototype, make it into a little project, talk about it, put it on YouTube, let people know that you're doing something exciting. And then you can apply for a grant. You can go to Startup India website. There are lots of grant schemes. You can come to Atal Incubation Center, which is, it's available at our university. It's also available at other places. And pitch your idea there, show your prototype. And then, if you stick to it, most likely you should be able to get a bigger grant that will help you finance your operations. Having said that, keep in mind that, this is not a overnight lottery ticket. And just keep in mind that 99% of companies, fail and they never really make any money. And so if you're just thinking this is a quick lottery ticket, no, it's not. But if you really want to build something and you can persevere, then, if you succeed, you will probably do a lot, you will definitely rise probably far more than your peers who are only doing, taking a standard job. And even if you fail, you will learn so much that you will, it will help you excel in whatever. Definitely something for you to consider. And while you are in school and college, I must say that before you start something, try to become good at something. You must have a good skill before you try to become an entrepreneur. Try to become good at something. Maybe you can become good at technology, good at programming, or good at selling, good at developing an idea and presenting it. So become really good at something. That's very important while you are in school and in college. But maybe towards final year of the college, you can build something on your own and try out an idea on your own, and even try it out in a school. Even at school level, you can try it out once you are at the senior level. There's really no age at which you need to do that, but just keep in mind that it takes up a lot of time, energy, and it does require a little bit of commitment. So if you can commit 1 or 2 years of your life without thinking about returns, then it's a path you should take. A third path that you could consider is research. As somebody asked, what if I want to build a missile? So if you want to do research, take up an academic career, recommend that you invest in a higher degree, get a master's or a PhD from a good university, because doing that will help you get a good teaching or a research position, either at a university or at one of the research labs like ISRO or Indian Institute of Science or DRDO and so forth. So those are sort of the career paths you can take and how you can take. And hopefully some of your questions might have get answered with that. All right. Let me unshare the screen and then we can talk. Yeah.
Naman and Kabir. Over to Hers, Naman, and Kabir.
Yes, ma'am. Kabir. Kabir.
As we have very less time, so start at once.
Uh, okay. Thank you so much, sir. So we'll start by talking about the competition that me and Kabir participated in, right? So, Kabir, would you like to talk about it? That you're here.
Yeah. So the details of the program will be, we'll have sessions of 1 hour long. There will be 2 to 3 sessions per week. We'll also give the students home assignments so they can participate and be engaged at homes. If there are more sessions needed, we'll provide them. And Naman can tell the details.
So, first of all, the program will be led by students from SNS and SNU, right? And also, we plan to make to show how to make drones at yourself and also understand some of the physics behind it, like how do they work, right? Then we plan to start teaching Arduino on Tinkercad. So Tinkercad is just an online simulator where we can create circuits and with or without Arduino, right? So after this, we can also start learning Python, which is a very popular coding language for data science and artificial intelligence.
So the basic timeline will be, we'll teach drones, basic of drones and how they work for 2 weeks. Then then Arduino, which is a very common language for basics, and Python for your first or second projects that you'll build. This is a video of us participating in the RoboCup.
This is all those interested student. Naman and Kabir, please put the registration link in YouTube chat box. Also, we will share with all schools through Gulfam sir, Anamika ma'am, Mayank sir, Ruchi Ratra ma'am, and Megha Boda, all 5-6 campuses. So, when I be starting this program, Naman, Kabir, and Harsh, please let us know.
So the link will be in the chat description on YouTube. You can fill that out.
When is the deadline of registering? What is the deadline?
So the deadline, we haven't really kept a deadline till now. So, but it would be ideally, it would be good if you could send in all your names and emails by Tuesday, right? So that we can create a list of all the people that are interested, right? And we'll try and send the circular by maybe tomorrow, right? So that everyone can check if they want to participate.
So I would request Anamika ma'am to keep in close contact with Naman, Kabir, Harsh, and a team of students, another student from SNU who will guide and take this program forward. So Anamika ma'am will be also there, and obviously Gulfam sir is there. So uh, that's it from my side. So you can take the program further. Thank you.
Would you like to talk more about RoboCup?
Please do,
Yeah,
because
sure.
we have 2-3
So
minutes left.
RoboCup was the competition we participated in. So RoboCup Junior is a competition in which robots are supposed to follow a line till the rescue zone, where it transfers 3 or 5 victims over a wall. We were able to reach the Asia Pacific round of RoboCup, where we placed 9th. So one major takeaway for me was 3D printing, which could be used to your advantage in a wide range of situations. So the team that won had built the robot from the ground up by designing and printing every part. Another example is, if you have a part that doesn't complete the task perfectly at hand, you can just design and print the part you need. With the help of 3D printing, the only limits is your imagination.
The competition was quite exhilarating and it tested your ability to handle stress and also work in a team. We enjoyed a lot and also learned a lot from our teachers and fellow competitors. My takeaway was that robotics is a field where being resourceful is a very important quality. Right? So what we call a jugaad, right? a lot of the time is an ingenious solution to problems that we might face while making a robot.
Would like to listen from Dr. Akash Sinha about this project which SNS and SNU kids will jointly take it forward, because obviously they will be mentoring and they will be taking sessions. So what do you feel about it, Dr. Akash Sinha?
I think it's it's a fabulous thing that the students have come up with. So I must congratulate the students who are doing this. And I must also congratulate you, ma'am, for encouraging them. And this is something, as I said, it's something that if kids learn early enough, this is going to be the future where a lot of jobs, a lot of career opportunities will be created. So people who get exposure to this early enough will definitely gain from it. I think the program seems to be very well structured. And whatever help I can do, I'll be happy to get involved. And so also I must comment that this competition that Naman and Kabir participated, they seem to have built a fairly complex robot, fully autonomous one, doing a variety of complex tasks, and it's quite impressive. They do that at a school age, huh? So again, many congratulations to you folks.
Anamika ma'am, are you ready to take this program forward with help of these two kids and a kid from SNU also, and obviously under the mentorship of Dr. Akash Sinha? So
definitely, ma'am. So I'll be more than happy to be a part of this program. So I'm really looking forward to it. Even I'm going to learn a lot of things. So that is very interesting.
Yeah, Gulfam sir from Vidyagan, are you from here? So both of you can take this project, help these kids, because they will be doing under guidance of Dr. Sinha, and I'm sure it will be great hit. Thank you. Over to you, Naman, Kabir, Harsh. So you can, do the final. Dr. Madhu Negi ma'am is here, so please invite them also. She is Vice Principal Vidyagan Bulandsahar.
Yes, ma'am. So thank you so much for such an insightful session on robotics, sir. I'm quite certain that at least some of the audience would consider pursuing a career in robotics. So we would now like to call upon Ms. Madhu Negi for giving the closing remarks.
Thank you, Naman. Good evening, everyone.
Good evening.
Good evening. Am I audible? Yes.
Yes.
Okay, great. Thank you so much, Mr. Akash Sinha, for 1 hour of a very, very insightful and interesting session. And definitely a welcome relief from usual topics that we are getting to hear nowadays. For me, it was a very, very welcoming, reprieve. I think, very succinctly put it across that, with AI and robotics going the rate at which they are moving forward, will very soon take over all the dirty, dangerous, and dull jobs of human beings. They have started already doing that to a small extent, but I can see a great potential in the future. And if this happens, just imagine where it leaves humanity. We will have the time and the space to achieve so much more. I thought you put it across so well in your talk. I know there is a lot of controversy regarding AI and robotics and how far we can go ahead with it. But I, like Zuckerberg, feel that it has a lot of potential, and it will definitely lead to the prosperity of human beings very in the near future. I'm very optimistic about this field, and thank you so much for addressing the queries of the students so well, and showing them how they can pursue this in case they are interested in this field, how they can pursue it as a career choice also. Thank you so much. This is the second time I got to hear you, and let me tell you, every time I'm hearing you, I hope that Miss Vinita keeps on, inviting you for much more such interesting talks in the near future. Thank you so much for taking your precious time out and bringing, at least for people like me who don't know so much about robotics, I learned a lot today. Thank you so much. I would also like this opportunity to thank Vinita ma'am. Vinita, thank you so much for heading the Nuclear Society so well, so efficiently, and for planning and organizing such sessions. Um, Mr. Gulfam Ahmed, he is for coordinating and assisting you at Dulhera, and Anamika, I think, is doing at the other end. Thank you, both of you, so much. Last but not the least, all the students, thank you for attending, for listening, and I'm sure it must have excited you, and I'm sure that some of you have definitely decided to pursue this as a career in the near future. Thank you, everyone. Please take care and stay safe. Good night.
Thank you for
Thank
such
you, Negi.
beautiful words, Madhu ma'am. And you, who knows that this evening, 15th May 2021, when we keep watching all, politics and all COVID, who knows that all the listeners and all the viewers who were asking such questions, one of them or maybe a group of them will come up and do something great for the humankind with help of this learning, and they
Exactly
pursue career.
Yes.
All thanks to Dr. Akash.
Thank
There
you.
are words. I'm speechless. The way you ignite and the way you take time and the way you are always saying yes for all sessions. Thanks a lot to Anamika ma'am, Gulfam sir, Madhu ma'am, and all the leaders, all the principals of all 5 campuses, Rupa ma'am, Billy Mathur, everyone who had given thumbs up for this. A big thank you to this technical team, Naman, Kabir, Harsh, and Amit. You 4 will be always there in all sessions because we require you, and without you, it is not possible. So thanks once again, Dr. Sinha, and we are looking forward for this new venture of workshop, which students are starting to get, and obviously you will be always there to guide them. Thank you so much. Over to you, Naman, Kabir, and Hers.
Thank you so much, ma'am.
Any last word, Dr. Sinha, would you like to say? Any last line?
Well, I'm just saying that trust me, I'm just as excited as you all. It's very exciting for me to get along with the students and work with them, and I've really enjoyed that. And I've had a good fortune of visiting our Shivnadar school. Now, maybe when opportunity comes, definitely would like to see one of our Vidyagyan schools also. I've heard a lot, and it's very good that I think. But this whole initiative of nucleus connecting campuses, this is really nice. I think at one level the university and school really need to connect. And so anyway, I'm all excited about it, and must congratulate you, Vinita ma'am, and everyone in the team for doing that. And then also I think a lot of congratulations to all these young little kids who are taking so much initiative. So thank you.
Thank you so much. So should we close, Naman, Kabir, Hers?
Yes, ma'am. So thank you everyone for attending this session of Nucleus. Looking forward
Thank
to
you.
another one.
Yes. Good night.
Thank you. Bye bye.
Good night.
Good night.
Stay safe.